Hello everyone, this is Taewei Wang. I'm doing a summary of the chapter number 6 from the book Business Intelligence, Analytics, and Data Science book. Entering chapter number 6, we are moving from prescriptive analytics, going to predictive analytics, and finally we reach this stage called prescriptive analytics. From the order of the textbook, it seemed like this particular chapter is a more advanced topic compared to the previous two chapters. But the fact is, actually, we are going backward to see some of the technologies and sciences that we caught from the management field and try to study some mathematical modeling of the business intelligence aspect. The reason I'm saying this is because my training is in production operation management, and the majority of the material that you can find from this particular chapter is actually coming out of a discipline. You can call this operation research or management science or mathematical modeling in business. All these leads to the thing we are trying to do here is called prescriptive analytics. From the opening example of this particular chapter, you can find that we are looking at a operational problem. And this problem is we try to use data and data analytics or, in current situation, some form of artificial intelligence, try to identify this thing, what we call the optimal solution or close to optimal solution in recommending human being to make decision. In this example is recommending decision to bus route. And you can probably imagine the goal of doing this type of problem solving or analytic exercise is trying to minimize cost for the school district or to maximize the coverage or minimize the time spent in arrange the bus route for the school kids. So all these terms you heard me saying about minimizing or maximizing, and all these are seeking for an optimal solution from a certain known variables or under some kind of uncertainty. The uncertainty is usually controllable in this type of model. So this becoming the label of the chapter called the prescriptive analysis. You try to find a solution for a problem. That I think that's what's going on here. And the term prescriptive also implied that you are suggesting a solution to some sort of thing. So if you have heard about Nobel Prize winner Herbert Simon talking about that he divide the problem into structured problem and unstructured problem, and we are looking at more a structured problem solution in this type of model. And but of course, evolved from the 1970 to today is almost 50 years. The technology change, the computing power change. We have a different view on the traditional decision-making model. The traditional structural problem solving sort of mathematical programming model usually focus on more certainty in terms of the problem. So the example will be something, if you have taken the operation management course, you'll be forced to do something like a optimal inventory level model. You have to derive a mathematical formula, and that kind of formula solve a certain problem, and that is a traditional prescriptive model. But nowadays, with the advance of the big data and the artificial intelligence, we can include more uncertainty into the modeling, and this becomes today's prescriptive modeling that we are talking about in this chapter. So in a way that to achieve this more sophisticated level of modeling, because you are using data not only to describe the problem or predict some phenomena, you even suggest a solution. And so this is in a way that more difficult to achieve and more sophisticated. And it may require the combination of the knowledge from both descriptive and as well as predictive modeling in the data analytic field to understand better the true prescriptive modeling or prescriptive analytic that you can perform in the data analytic area. So again, you can see the example that the keywords there is the maximization model. So you try to maximize, and that is trying to find some sort of optimal recommendation in some situation. Now, typical topic or research or you can say example can be found from the journal outlet or magazine that is coming out of operational field as well. Inform is actually a very probably the largest operation management or operation research academic society. So we are looking at more or less even today this kind of prescriptive analytic modeling can apply only at the operational level. So in a way that if you think about would you be trusting the computer modeling for you to make a strategic decision? That will be something more difficult. For example, you may be able to tell the store manager how to set up a price for a product, and you can trust probably the computer modeling to set up the price for the product for you. But if you are investing in a future technology, say for example, Tesla has invested in a lot of this solar panel adventure, would you be trusting this prescriptive modeling and try to optimize your portfolio using that particular model? So the answer, if you think about the different type of these two problems, investing in the new adventure of Tesla stocks compared to investing or changing the price in your store, those are decisions at two different levels. So I would roughly say that as up to today, we are still looking at prescriptive analytic apply in only the operational area, not so much as strategic decision. In a more strategic decision, the human's common sense or the intuitions combined with descriptive as well as predictive analysis is probably more likely situation for you to invest. So let me give you another example of what I have learned at least 25 years ago when I was a PhD student. And one of the topics we were studying in the operation research field was something called the yield management. It sounds like a fancy word, but it's a fancy word, but it is not. It is something about pricing model. And have you ever think about why airline ticket change minutes by minutes sometimes, depending on how many people are clicking on the link and how the ticket sells in the current speed, and how do they manage that kind of model? So this is actually one of the classic pricing management or pricing optimization model. For airline, they are trying to balance between something called how many tickets they can sell compared to how high the price they can sell. Because the more ticket you sell, the more revenue. The higher the price you sell, the higher the revenue. But unfortunately, you can increase both these two variables at the same time. So you cannot increase, because when you increase the price, fewer people will buy. But when you reduce the price of the ticket, more people will buy, but your profit will be less. So how do you balance? So you try to strike the balance, and this balance is what we call as the optimal solution. So the airline and the consumer, they are playing the game, try to predict each other and try to figure out which way is the best way to optimize from airline's perspective their profit. And this type of prediction, even though there are a lot of uncertainties, can be modeled into some sort of mathematical modeling and using probably simulation or some sort of a goal-seeking algorithm that will be introduced in this chapter, and you will understand roughly what is the best pricing model at a particular point in time. Now, it's summarized by your table 6.1 from the textbook. You see there are typically six, seven different type of model that we can use to build prescriptive analytic in the business intelligence area. And all these are very traditional operation research models. And it's sort of like we are packing the entire semester, one semester work of management science that into one chapter. So we will not go very deep into the modeling, but I will introduce and get you understand the terminology and probably show you where to find appropriate tool in the tool like Excel. One of the pattern you can see from table 6.1 is that the method, the model that you're looking at from top to the bottom is actually evolving from a more certain model. Certain model means that the variable, the value, the number that you're looking at are very certain. So you can pretty much build a very certain decision. The earlier example I used, say for example, inventory control for a very matured product is typically in that particular area. And the model that go to the bottom, the more you go to the bottom, they try to include variables and method, try to accommodate more uncertainties. One interesting word I like to share with you is this word called heuristics. When I first started as a business student, I had a engineering training before. I cannot quite understand what heuristic means, but later, after I started studying business problem, I suddenly realized heuristic means that you cannot really find the solution, and you try to find something close to a solution, a acceptable solution, that is called a heuristic. So you cannot find the optimal point, but you find so-called the good enough solution. That's called the method of heuristic. So even though that is not 100% proof method, but it gives you enough foundation, say 60% confidence for you to go ahead and make your decision. Now, in the world of investment, if you can be right 60% of the time, you are already making money, because it's kind of like gambling. If you can win 60% of the time, and if you bet the same amount every time, long term, and, the more you gamble, the more you will win. That is just the simple probability problem. So the foundation of prescriptive analytic is on mathematical modeling. So you can see that we have a mathematical relationship. Somehow you have to find out, discover the relationship, or at least you have a best educated guess about what the mathematical relationship is, and introduce the variable into this model, and using the either simulation or hard quantitative method try to find out the optimal result, and that is what we're looking at here. Some more examples are presented in table 6.2 in financial analysis, marketing, manufacturing, accounting, transportation, and so on and so forth. You will find something very interesting here, that is that you look at the column number 3 in this table, you see a lot of this called the cost or profit or rate here, cost in particular. And this tells you that we are looking at a very operational level sort of a decision. So it can be in the manufacturing, we're looking at the transportation cost, we can look at the inventory cost, or some other human resource like labor cost in producing a particular product. And looking at the financial, you can find out the portfolio, the profit in your investment portfolio. the earning, how much you can generate, how can you maximize your profit in a turbulent environment. Or in transportation, you can minimize the cost or try to find out the shortest time that you can identify to sort of in a traveling situation. Imagine this situation that whenever you try to travel for leisure or for business, have you ever tried to go into one airline ticket website to another, and also within the same website you would do, say, change different airports. Say, for example, in the area we are in the Springfield area, and if you live in Springfield, you might check the price of from St. Louis or Chicago and try to figure out what is the best way. And in your mindset, you try to think in terms of, well, if I drive to Chicago, it will take me 3 hours, and I have to pay for the train ticket or the gasoline and parking costs. Compared to if I drive to St. Louis and fly from St. Louis to my destination, and it's a shorter drive, but usually the airplane ticket in St. Louis is much higher, and you now have this concept of how much I can save if I drive to Chicago in terms of price ticket. I can justify that my driving to Chicago instead of flying out of St. Louis. So those decisions, when you try to balance the total cost, is actually the fall right into the category of prescriptive analytic in business intelligence. And one more example, that when you try to minimize your tax return or tax that you need to pay every year, and if you use a software for, say, for example, TurboTax. So if you're accountants, or actually everybody, that when you are at the time of filing tax, especially when you start to make a lot of money, then the TurboTax will ask you, do you want to switch from the so-called standard deduction models or itemized deduction model? That is also a optimization decision, which way you can get you the lower tax. Then typically the software will calculate all the information that you have and try to give you a recommendation, and you can take that recommendation, and in a way that the TurboTax or any tax filing software already is conducting prescriptive analytic for you in that particular problem solving situation. So again, not all problem can be solved or recommended by a prescriptive analytics, and it depends on the uncertainty. The more you have uncertainty, the less likely you will have a prescriptive model. But of course, that with the introduction of AI technology, the AI can actually become some sort of what we call the knowledge acquisition engine. So with the support of AI, we are moving actually more toward to the right in terms of building the prescriptive analytic model. And in today's industry today, other than you have encounter probably a very sophisticated company using the AI solution or cloud-based AI solution or big data solution, most of the organizations are still relying on tools, especially a spreadsheet, Excel spreadsheet or Google Sheet, to solve their prescriptive operation model. More or less likely you will do this cost benefit break-even analysis or simulation analysis. All these are the example of prescriptive analysis. And so later I will show you a little bit where to find the plug-in, the add-on software, make your software or the spreadsheet more powerful in the Excel environment. A typical Excel spreadsheet example for prescriptive analytics is something like a model. And many of you have this experience in other courses of writing formula and using formula to kind of calculate and derive the number. And actually, when you have the formula and the relationship between different cells, now you can change, say, for example, in this case, the cell number, row number 7, E7, and E8. These two can be changed and simulate to a way that you can find the payment. And when you do the simulation, this is a long payment simulation. You can do a mental calculation of what is acceptable the loan payment I can afford. So when you are making a decision on whether you want to apply for the loan, you can decide it on, well, should I wait a little until the interest rate drop, or should I go ahead and apply for the loan and purchase this house? And so that is a decision that you can make here. Now, the ability to build this model should be further strengthened because this is a very, very common and typical situation you will be encountered in many business situations. And with the hope of our business program from our college is that we wish every one of our students, when you graduate out of the school, you can be sort of at least very knowledgeable about the spreadsheet software. You can do such kind of prescriptive analytics with very high confidence. Or at least that you know enough that in the future you can watch YouTube video or search for a video like my video tutorial to find out how to do a certain problem that will be desirable. And the other very likely model you'll be encounter other than a simple formula-based simulation, static simulation, is linear programming. And linear programming is a very mature field of calculating optimal solution based on known variable, and it includes some method of doing sensitivity analysis to give you a sense of uncertainty or uncertainty management. Now, in the past, in the earlier time of linear programming in the 1960s and 70s, right after World War II, that in that particular decade or so, or 2 decades, linear programming was solved by hand calculation, which is not very fast or efficient. Nowadays, with the computer simulation, we can solve linear programming very quickly. So it has been applied very sophisticatedly in many different areas. As a matter of fact, a lot of this artificial intelligence use linear programming model that was developed as early as in the 1940s and 50s to today, and apply in large data and fast calculation to be computed. And one of the problems this type of model was not so useful in the past is because you can design a program, but the calculation or the processing power is not good enough to find a solution for you. But in today's environment, these type of solutions are doable. In linear programming or any kind of mathematical programming has been applied in many situations. For example, in this case, we have a scheduling problem, or in some of the other more, say, day-to-day operation, you will encounter, say, a queuing operation. So you go to Disney World and try to figure out how long you need to wait in line, and a Disney company try to figure out what is the best way to shorten the line, increase their capacity, but at the same time they want to maximize their profit, and also they want to satisfy their customer. How do you balance all these different concerns are typically using in mathematical modeling. And one classical example, if you take any management science or production operation management course or service management course, you'll be encounter is this called the product mix model. Let me try to explain as much as I can in like 30 seconds or so about this kind of problem. So basically, if you have a company selling 2 or 3 or a mix of product, some product has a higher profit margin, some product has a lower profit margin, but they have a different labor cost and depends on the unit you're trying to produce. So in the way that you're trying to balance between the combination of how many of these units you'll be selling, because high price of item, yes, you can, the more you produce, you can produce more, but at a certain point in time you will exceed the market demand and nobody will buy your extra product. So there is a balance between how much is the high price product you want to spend and how much the low price product you want to invest. There is a right balance between the product mix, and so this problem is try to solve the problem here. So you have all the data here, the labor cost, the material cost, the unit, how many unit you can sell, and what is the maximum demand on the market. Of course, if you look at the right column, the limit is usually experience. You look at your historical data and understand, okay, product one versus product two, how much we can sell in product one at most in a particular month, and how much you can sell product two in a particular month, so that you get that a sense. It's uncertainty, but we sort of like model them into some sort of a certainty model. And this later, if you continue to read the chapter, become a sensitivity analysis. You can change something what they call upper bound, lower bound, and try to figure out where is the boundary when your model start to mutate to a range that your model is not useful. And once you have this kind of a problem, you can then create a model. This is a mathematical model, very typically. And the key here is that in the middle part of this diagram here, you have this maximizing. Again, earlier I mentioned something about maximization or minimization, and subject to some sort of constraint. And you have this inequality equation that to represent the constraint. And once you put them all this in here, you can throw them into Excel spreadsheet to solve the problem. And here I'd like to kind of take you to Excel spreadsheet to show you where you can find these feature. I will not show you how to do it yet, but this is somewhere that your other course maybe you will encounter and may take a look. And there are also, again, a lot of YouTube video showing you how to do this in Excel. But I would like to show you where you can find in Excel. So a lot of this Excel function used for business analytics or business intelligence are hidden or actually not directly included in the default feature of Excel. To enable those features, you go to options in the Excel. When I click files, and you can go into options. And these options, you can see there are a lot of this option here. And one of these options called add-in. Add-in is the place you can actually install other software. Actually, there are a lot of software companies try to build add-in so that you can use Excel for many different purposes. Say, for example, you can use Excel to access a database, and those Excel can be an analytic tool for large database. And for the default optimization model, it's hidden under analysis tool. And there are two analysis tools. The basic one is analysis tool pack here. You can go in there and look at some of the options we have here. Analysis tool pack, VBA, there are solver adding, and so on and so forth. Once you have that, what you will be seeing here is, I think that Excel, it takes a while for it to enable. You will have some tools under the data tab, something called the data analysis and solver that you can use. So this is the solver that you see from the textbook that they tell you how do you build a model, and you can enter the formula here, and you can try to play with it and solve some of the prescriptive analytic model in here. So again, another example of using the and these are the constraints that you can enter from the model here, and it's actually fun to do. But with the purpose of our class, we're not actually introducing every aspect of software that can train you, and we'll focus more or less on the feature that we can quickly pick up and use in this course. But the purpose here is to let you know that there are feature out here that you can use but require additional learning. And models are very commonly used in Excel spreadsheet, including dynamic programming, Go programming, investment modeling, linear programming, network model. All these has their similarity in the center. They have mathematical modeling, and all of them require some sort of optimization in the concept of give you prescription in decision making. So the challenge of building this type of program is, one is that when we talk about maximizing or minimizing, usually we set up only one goal for the program to achieve. So when you try to achieve or optimize a goal, that you might be sacrifice other criteria for success. Say for example, when you try to minimize the cost, you might be sacrificing the profit you don't even know. So this is a typical management problem when the production environment manager try to minimize the cost. Well, on the sales environment, they are maximizing the profit or revenue. And those are actually conflict to each other. So when you have multiple goals, the modeling become more difficult. In Tesla's earlier year, I mean, not too long ago, they have this problem called the production problem, and they can actually sell a lot of car, but their production line cannot catch up. And one of the when they catch up the production line, the cost cannot be managed, and that is a typical example of in the production or manufacturing field, that you balance between the sales volume and the limitation, the cost, and the potential quality problem that in the production environment. And the other one problem of the programming model is the uncertainty handling. And this is usually handling through some sort of a sensitivity analysis. You try to change and simulate the variable or parameter that you use. Say, early example, in the financial loan example, we changed the rate, the mortgage rate, and try to figure out what is the mortgage rate will impact on the monthly payment. So when you try to change the rate and figure out the best rate for you to go into the market, you are doing sensitivity analysis. Another very popular example is something what we call the what-if analysis. And actually, we just gone through an election years, and you will typically hear people saying about what if so and so was elected, and what's going on next? What if the other person is going on? Similar application has been seen over and over again in the operation, in the day-to-day operation business world. What if the oil price go up? What if the gold price go down? How does that impact your portfolio, impact your investment? So those other things can be simulated and estimated, and based on the risk you can take, these simulation results will give you some foundation for decision making. And when the simulation being used in a context such as this one, this become a goal-seeking example. In this case, you try to find the optimal interest rate, try to get your return into the range that you are acceptable. And uncertainty can be handled also through something called a decision table, probability. And in this particular case, people usually use this concept of payoff and probability and try to calculate the maximum payoff and to handle the uncertainty in many decision-making situations. So in the example of decision table or decision tree analysis, the text will give you an investment example. So when you try to invest, you are always invest in a uncertain market, but you don't know what the market will be next week, next month, or next year. But your goal is the same. So your yield will be depending on three situations. For example, it's growing, or it's stagnating, or it has some sort of inflation. Each one of this possibility has a chance to happen. So if you can estimate some sort of probability and get information, and there's a what if situation here, and you can somehow adjust your portfolio. Portfolio in this case is the bond versus stock versus deposit, and how do I adjust the percentage to yield the highest return that I can get, and put them into a decision table that you see. And this is not the decision table has accommodate the uncertainty or probability in here, but you can clearly see that how each one of this category contribute to different return in terms of your portfolio. And by the way, this type of table are also used in performance evaluation in many situations. And now when they accommodate the uncertainty of the situation, they can come up with a different scenario. And for more sophisticated calculation, you can actually calculate something called expected value, and that expected value can help you to estimate which decision is probably the best combination for you to go to. But of course, in our short chapter, we just introduced this is the value there, the method there. Then for a more sophisticated way of using this model, you have to learn individually each one of this method in different places. Again, I would say that in today's YouTube, the social media environment, you can very easily find simple tools and tutorials show you how to do this. But from the learning perspective, you have to know there are things out there. These are the technique is already out there, very mature. There are simple solutions out there. So next time when you encounter similar situation, you can quickly think of, yes, we have this tool out there. Let me do a little research in YouTube and find the solution there. And simulation is also another very popular tool, and you probably have learned this already in many operation related courses. More sophisticated simulation, such as weather predictions, are also widely available out there, and you can easily find the models and tools out there. The benefit of your textbook is they give you a lot of this reference that you can go in there, and they provide you with popular software company provide software at each different category. You can easily find those category for you to use in the future, or at least as a starting point for finding solution. For simulation tool, or most of the tool providing prescriptive analytics is this in here. It's not a complete list. Some of the things I know, some of them are not very familiar. Say Lumina, I think they have already, I believe they are purchased by SAP already. And you have Oracle Crystal Ball, Crystal Solution, and so on and so forth. But again, most of them are traditional operation research company. And so once you know where they are, what kind of problem they are solving, you can do more research in the future in your career. Try to identify solution for the job you're working on. And that will be the summary of your chapter number 6, Prescriptive Analytics in the Context of Business Intelligence.